Have you ever wondered if technology could finally tear down one of our biggest communication walls? The one that keeps us from understanding each other perfectly? Well, today we're diving into a really cool frontier where AI is learning to do just that, to see, to understand, and to translate one of our most beautiful and expressive forms of communication, sign language.
And to really get why this is such a big deal, you have to start with this number, 1.5 billion. According to the World Health Organization, that's how many people around the world are affected by some level of hearing loss. And look, that's not just a statistic. That's a huge community of people, of families, facing communication hurdles every single day. So, that brings us right to the heart of the problem, the communication challenge itself. Before you can even think about teaching a machine to do this stuff, you have to appreciate just how complex sign language really is.
Yeah, so the first thing you have to know is that sign language isn't just about what you do with your hands. It's this incredibly rich, full-body experience. It uses gestures, sure, but also facial expressions, posture, a whole shebang to create meaning. And here's the real kicker. There is no single universal sign language. There are nearly 200 of them, each one with its own unique grammar and rules. So the idea of creating one single translator that works for everyone, that is a massive, massive challenge. Okay. So faced with that level of complexity, where did researchers even begin? How in the world do you start teaching a machine to see and understand signs? Let's take a look at the very first attempts. So early on, the whole field kind of split into two main camps. On one side, you had the hardware folks. They used things like data gloves and wearable sensors. Now these things were super accurate. They could capture every tiny little twitch and movement, but they were also bulky, really uncomfortable to wear, and super expensive. Then on the other side, you had the software approach, which just used regular cameras. This was way more practical, right? Much less intrusive, but its performance could get totally thrown off by simple stuff like bad lighting or even just a messy background. Both of those approaches had some serious limits. Neither one was the perfect solution. But then a turning point came that changed absolutely everything. And that was the deep learning revolution. With modern AI, we got a whole new way to attack this problem. Let me break down how it works in a really simple way. First, a camera just records the sign. That's the video input. Then, the AI gets to work, pulling out all the key features. What's the hand shape? How's it moving? Things like that. Step 3 is classification. This is where it's like a matching game, comparing those features to a giant library of signs it already knows. And finally, boom, you get the text output. So how does the AI actually learn to see all these patterns? Well, researchers combine two really powerful techniques. Think of it like this. One part of the AI, called a CNN, acts like the eyes. It gets really good at recognizing specific things, like the shape of a hand. The other part, an RNN, acts like the memory. It understands the sequence of those shapes over time to figure out what the whole gesture means. It's this combination of seeing and remembering that's so powerful. And just like our own brains, these AI models learn from experience. It's pretty simple, actually. The more data you feed them, the better they get. If you train a model on a small data set, its accuracy is going to be pretty low. But as you can see, as you give it more and more training data, its performance just skyrockets. So with these incredible new AI tools, it really seemed like the problem was just about solved. But researchers were about to discover another, much deeper layer of complexity that a lot of people had been overlooking. It turns out, it's about way more than just the hands. You see, the hands only tell part of the story. Things like a raised eyebrow, a slight tilt of the head, a shift in your posture, these are called non-manual features, and they are absolutely essential. They provide grammar and context. For instance, you could have the exact same hand sign mean two different things. One's a statement and one's a question. The only difference? The look on the signer's face. If you ignore those clues, you're going to get the translation dead wrong. And the data on this is just crystal clear. Look at this. Studies found that when you train an AI model to only look at hands, you get a certain level of accuracy. But the moment you also train it to recognize facial and body movements, its accuracy shoots way up. Some studies showed an improvement of over 17%. That's a huge leap in performance, and it all comes from teaching the AI to look at the whole person, not just their hands. This incredible nuance is what makes this whole thing so darn difficult. Here's a great example from Arabic Sign Language. The signs for brother and sister start with almost the exact same hand movement. So how can a machine possibly tell them apart? Well, the difference is incredibly subtle. Maybe a slight change in placement near the end, or a specific facial cue that goes with it. And AI needs to see tons and tons of examples to learn how to spot these tiny but absolutely critical differences.
So while the progress we've seen is nothing short of extraordinary, we're not quite at the finish line yet. To get this amazing technology out of the lab and into the real world, into our hands, there are still a few more big hurdles we need to overcome.
Right now, researchers are tackling three major challenges. First, there's a serious lack of massive, diverse data sets. We just need way more video, from tons of different signers to build models that are truly robust. Second is translating continuous sentences. It's one thing to recognize a single word, but it's a whole other ballgame to understand the flow of a real, natural conversation. And finally, the tech just has to be practical. It needs to be accessible, affordable, and something that can run on your smartphone, not a supercomputer.
But you know what? These hurdles aren't dead ends. They're just the next wave of innovation in a field that holds so much promise to completely change how we communicate. So what does this all point towards?
You see, this journey to teach AI sign language, it's about so much more than just technology. It's a real push toward a more inclusive, a more connected world. It forces us to think about what language and connection even mean. And as this tech keeps getting better and better, it leaves us with a really powerful question to think about. As AI gets better at understanding our most human forms of communication, how will it change the way we connect with each other?